Hello everyone and welcome back to the channel. In this video we are solving the practice problem 2.14 and practice problem 2.15 where we will apply the Y delta transformation technique we just learned. This problem shows exactly how useful this method is when resistors are neither in parallel or in series. Let's get started and walk through the steps together. You remember the transformation from delta to y and y to delta with having the transformation figure that I illustrated over here. So if you want to transfer from y to delta, what we are going to say? We are going to say that the numerator is all possible product of two resistors in the Y network, which in that case is R1, R2 plus R1, R3 plus R2, R3 for all three combinations, for all three RA, RB, and RC. But in the denominator, we are looking for the resistor which is opposite in the Y connection. So if I want to find RA, what is the opposite resistor in the Y network? It is R1. And if, for example, I'm looking for the resistor which is opposite to RB in the Y network, it is R2. And finally for RC should be R3. Now, for better understanding, we are going to solve two examples. The first example is, we say that transfer from Y to delta network. So obviously we know that if I want the delta network, first of all I should calculate all the possible product of two resistors in the Y network. So one possibility is R1 times R2, which gives me 10 times 20, plus R2 times R3, which can be, I can show with another color, R2 by R3, which product of 20 times 40, plus R1 times R3, which is equal to 10 plus 10 times 40, yes, 10 times 40, which in that case is equal to 1400. So meaning that if I want to find my RA, RB, and RC, we know that the numerator for this all three is 1400, and denominator for RA is the one that it is far away from RA, the opposite one, which is R1, which is equal to 10, and for R2 is equal to, it is 20, and for RC is 40. And if you divide, you're gonna get for here 140 ohm. For the next one is equal to 70 ohm, and for this one is equal to 35 ohm. Let's solve practice problem 2.15, which is a little bit harder. Here it says that find equivalent resistor and find current passing through this circuit I. So how we can find this? As you look at here, you see that the resistors here are neither in series nor in parallel. But what can I say? I can do transform from Y. You can consider this one as a Y network. Yes. And I can replace this Y network by one delta one. So How is my delta 1? Over here I can say that I have 240 volt voltage source passing through this terminal. I will have my 6 ohm resistors. Then rather than that, I can replace this one by 1 equivalent delta 1 which I can call this one as RC. I can call this one as RB, and this is my RA, which is connected to the rest of the circuit, which is 20, and this is going to be connected to 100. Yes? Now we are going to find RA, RB, and RC over here. So we remember that we can easily say that if we had such a thing, RC, let's change my color. So we had RC, we had here RB, and we had here RA. Here we had R1 and R2 and R3 over here. What is my R1? I can consider my R1 to be 48, and I can consider my R2 to be 60, and my R3 therefore is the other one, which is 40. So in order to find RA, RB, and RC, first of all, for numerator we need the product of all possible two resistors in the Y network. So I can calculate that one separately. I can say that my numerator in all resistors is 48 times 60 plus 60 times 40 plus 40 times 48, which in turns is giving me equal to 7,200. 7,200, 7,200, and 7,200. And the denominator for RA is the one which is far away from here. So far away from this resistor is 48. For RB is going to be 60, and for RC is going to be 40. Therefore, my RA, if I divided 7,200 by 48, I will get 150 ohm. And for RB, if I divide, I will get 120 ohm. And for RC, I'm going to get 180 ohm. Okay? Now I can say, I can replace this value over here. It's going to be 150. RB is going to be 120, and RC is going to be 180. Now, if you look at this circuit, obviously 20 and 120 are using both the same two nodes. Therefore, they are in parallel, and 100 ohm resistor and 150 ohm resistor. Also, both are using the two same nodes. Therefore, these two are also in parallel. Therefore, I can simplify this by saying that 120 is times 20 over 120 plus 20, which gives me something like 17.14. And on the other hand, 100 and 150 are in parallel as well. 100, 150 over 100 plus 150, which this one, if you calculate, is give you 60 ohm. So then after, if I redraw my circuit is the one with plus minus 240, current passing through here, is visited 6 ohm resistor, and then over here I have 180 ohm resistor. This is connected to two resistors with this amount. Now it is very simple to follow. First of all, 60 and 17.14 are in series, which produce 77.14, and these are parallel with 180 resistors. So 180 times 77.14 over 180 plus 77.14. If you calculate, is equal to 54 ohm. And then this 54 ohm can be added with 60, but with 6 ohm resistor that are in series. Therefore 54 plus 6 is going to give me 60 ohm. If I redraw the circuit, I'm going to have 240 with connected to 60 ohm resistor, and therefore finding the current is simple. 240 divided by 60, which gives me 4 ampere. And that is for the problem 2.14 and 2.15. You saw that our equivalent is also 60 ohm. As you can see, using the Wye delta transformation make it much easier to simplify and solve tricky resistor network. If you found this helpful, please like, subscribe, and leave a comment with any question or future topic you like me to cover. Thanks for watching, and see you in the next video.